Thank you all for coming. This is the 2022 AC Sparring Conference. So we are here to have a fun time, to have a great time together. Thank you to all the students and all the participants and all the attendees that are joining into this meeting. Here we have a great speaker. Her name is Paula Greve. And what I can say about her is it's an amazing person that I have at the moment as a speaker to this conference. Paula is a technology leader who is currently working as a software engineering manager, a principal software engineering manager with Microsoft, working on the customer insights product. Prior to this, Paula has worked as a distinguished engineer and engineering and data science leader within cybersecurity on both McAfee and FirstPoint. Paula has over a dozen patents associated with security innovations needed to meet the demands of today's data-heavy world and has presented at numerous data analytics and cybersecurity conferences. Outside of work, Paula has 2 children, one boy and one girl, who are in the same field as her, STEM. And they will be pursuing the careers in that field, of course. Paula is passionate about recruiting and retaining people into technology, as she knows how this has enabled her to live her best life and wants others to also have these opportunities. On the other hand, for hobbies, she loves hiking in the woods. So let's have a welcome to our speaker, Paula. Thank you for your time, Paula. Thank you for joining us, and we love to have you here.
Oh, thank you so much, Edwin. It's been just a pleasure to get to know you, and thank you for everybody who's making the time to come here. And definitely, I want to leave a lot of time for questions. So please feel free to ask them, and we'll answer.
Oh yeah, sorry to interrupt you. For those who wants to make a question, we have the chat on the right side of the screen. So please click on the 3 bars, and you can see the chat. And just typing in, I will be paying attention to those questions, and I will transmit them to our speaker, Paula. Sorry to interrupt, Paula. Now you're on the start here. Go ahead.
No, that's great. That's great. And you know, it's funny because I started my career with the software engineering, but as the data came in and I could see what we could do with the data, and machine learning evolved past data mining to machine learning and data science, you know, I continued to grow my career. And I think that's what's really exciting. And that's why I think that whether you want to be a lawyer or you want to be a CFO, understanding data and technology is so critical to your ability to be successful. So we're going to talk a little bit about that during this talk. Go ahead and go to the next.
Thank you.
So a little bit about why I chose to go into technology. When I was in high school, I was really good with math and science. And my father kept telling me I should be an engineer. He was not an engineer, but he kept telling me to be an engineer. And my mother kept telling him to back off and let me decide what I wanted to do. So it was great that I had a mom who advocated for me and a father who also advocated for me. So my father arranged for me to go in and meet a bunch of the people he worked with. My father was a business analyst. And in bringing me in, I met a physicist, I met a mechanical engineer, and I met a knowledge engineer. And the knowledge engineer talked all about algorithms. And she talked about having a monkey, a box, a stick, and a banana, and how do you write the most optimum way for the monkey to get the banana. And it was really interesting to me, and the way that she talked about it, and the way that it's like, oh, wait a minute, we can do this, and then we can be smarter than what we as humans think we can be. I got really excited, and I decided right then, literally like that day, that I was going to be a knowledge engineer. I then went into doing software. I then asked my dad, what do I need to do to be a knowledge engineer? And he connected with me with her, and I was able to follow up with her offline. In fact, I still talk with her on occasion. And she explained all about software engineering and knowing artificial intelligence and expert systems and such, because back then that was the buzzwords. So I went in and changed my school schedule for my senior year in high school, and that's what I was going to do, and I was going to make a difference in the world. When I graduated college, I was only able really to get a computer science degree rather than more of an AI degree because it was undergrad, and I knew I wanted to do technology, and so I worked really hard to find a company that wanted me to actually build software solutions and do coding and be technical. And so I went to one company that was smaller, and they asked me the right questions. This was the years before the technical interviews and that kind of thing. But they gave me essentially a technical interview. Go on the whiteboard, show me how you would design this, translate this to hex, translate it to octal, and just getting to do some of that just excited me. It was a challenge. So when they offered me a job, I was like, yes, that is where I want to go work. And I went there, and they did cybersecurity. And that's how I learned really about cybersecurity. My first week on the job, we had cybersecurity 101 with somebody who's a PhD who's gone on to work at Sandia National Labs in cybersecurity, and just learning it. And then it got to be like a game of strategy, because I need to when you're doing cybersecurity, you've got to protect against everything, but the hackers just need to find one weakness to get in. And so how do you think about that? How do you minimize the damage? And it was fun for me. And so that's why I went into cybersecurity. Throughout the course of my career, I've gotten lots of opportunities, and when I didn't, I'm like, I wanted to do more with data, so I went back to grad school while I worked.
I think we're having some technical difficulties here. Let's see if she can connect again. Oh, okay. She's connecting.
Back and forth from having bigger teams to littler teams. And I hope that I don't know, Edwin. I lost you. It's saying my Wi-Fi is good, so hopefully people didn't lose me. But
We lost you for some seconds, but
okay.
now we are connected again. So please feel free to continue.
Perfect. But yes, so that was a big thing, to go back to school to get my master's while I was working, and to
Yeah.
return to school, because at that point it was not going to be a pay increase or anything like that. My experience was worth more than the education. It was really about getting additional education so I could continue to grow and do more. Do you want to go to the next slide?
Yeah.
So throughout throughout my career, I've really been watching to see what people do and how they're successful, how they sell their ideas. So at grad school, not only did I learn all about expert systems and artificial intelligence and data science and data mining, but I also learned how to come up with a project, how to sell your project, because you had to do a project to graduate. So you had to convince your advisor that your project was worthwhile, and how to talk about your project and the successes. And those skills I see other people doing all along. And I think that if you can learn technology, you're going to be much more suited to do this. A great example is, probably about 10 years ago or so, maybe only 8 years ago. Um, yes, it was more like 5 to 8 years ago. I was at a security conference and I listened to a lawyer from the ACLU. He had gotten very frustrated because he was trying to explain about the lack of privacy controls in Facebook at the time, and how the data and how people were being much more vulnerable, and nobody was listening to him, and nobody was listening to him. So he took a long weekend and he learned how to write an app for Facebook, and he wrote an app that would show you who all could see your data because of Facebook's lack of privacy controls. And he did this in a weekend. This is a lawyer, no technology, but he wasn't afraid to learn, to go find a tutorial. When he
Wow.
built that app, that changed the story. That app was then something that people were using and they were shocked to see. And then that helped change that. So this is the things that as we go up and as we try to make points in the world, as we try to change the world, as we try to adjust our careers, having the confidence and having the capabilities to go and try and learn something so you can find the data to make the point and show it in a really powerful way is really critical. Like with COVID, I know all of us have been really drastically impacted by it, and some of
Yeah.
us more than others. But it was seeing how different people presented the data differently as to the impact. And a lot of this data they got by scraping CDC websites or scraping other public health websites and understanding what was going on, and being able to communicate that in this area, 1 in 6 people lost an immediate family member. In this area, 1 in 10 people died, from COVID. And being able to scrape that, to talk about it that way, is much more meaningful. And this is all things they did with technology. And another area that I think is really powerful is technology can be used to improve your life. When I was an engineer, one of the managers who reported to me, her she had an MBA, and her son was diabetic. And when you have type 1 diabetes and you go through adolescence, your blood sugar goes all crazy because your
Yeah.
hormones are going crazy. And it was really hard for her son because he had to check his pump in the restroom. It was hard for her because she'd get called from the school nurse and all of that. And so at that point, MongoDB was relatively new. And so we worked and we established a MongoDB cloud that was public domain. And then one of her husbands had a friend who wrote apps, and they wrote an app so she could check her son's insulin level. So her son's pump then went to this MongoDB cloud and communicated out. He could check the app on his phone so he could easily see what his blood sugar was. She could check the app at work and know not to worry about him, or to call a teacher and say, he's not paying attention. You need to give him something to eat. And, that really made a big difference in her life as a parent. It
Absolutely.
made a difference in her son's life. And this was, once again, knowing what technology is out there, not being afraid to try and pull this together. They actually used a Facebook group to go ahead and recruit more parents of diabetics who had technology skills. So, I just talked about how Facebook was poor with privacy at one point, but here was an area where Facebook was really powerful because it connected a group of people who could then go ahead and take this thing that we did just for her and her son, to make their lives easier and expand it. Um, and there's so many things you can do with fitness trackers. My grandmother refused to wear one of those "I've fallen and I can't get up," but she walked all the time and counted her steps with a little pedometer. If fitness trackers would have been around there, we could have convinced her to use a fitness tracker. And those, you can configure to have built-in fall detection and that kind of thing, so that we as people who care about my grandmother but wanted her to be able to continue to live independently could have done that with her having her pride, and done it in a way that spoke to her. And so this is just so awesome that if you look for all of these things that we have, I know somebody who uses their Apple Watch to keep track of when their heart rate gets up, and they can tell that they're starting to come down with a virus now. They're that in tune. And so they take their zinc and stuff before they even feel it. So these are things that we all are empowered to do. There's a lot of apps out there, but there's a lot of opportunity for us to pull apps together, to pull the data together, to do our own thing. And that gets to the next thing, is that technology can be used to make money. So talking about all the data that's out there, and you talk about how do you go ahead and do your fantasy leagues if you're into fantasy leagues and win the fantasy earnings from your friends. You can do that. If you talk about all of the data that's out in the stock market, you can pull that in and you can build your own quant. There's so much open source technology out there. Look to see what's out there. Try and understand what the market is. Figure that out. You can track airline prices. At one point, Bing had this is the best time to buy your price to go to Toronto based off of these things. And it's still there, but it's a little bit harder to get to in Bing now. But you can do that. Gas prices. My guess is, I'm in the US, but my guess is gas prices are also not doing fun things in Canada right now. And Google Maps shows the gas prices around there, but we also know gas prices change. You can scrape all of this gas price information and you can figure out where is it that you can go to get the cheapest gas, what day of the week's the best day to fill up. And then that way, then you're going to be saving yourself money. So this is all technology beyond giving you a career where you're enabled to do these things for people. You're also enabled to build these things to save money and do all of this. And yes, Sam, the bus apps are great. There wasn't one in Cork, and when we hired Cork, Ireland, and we hired an intern, and that was one of the things he did, because Irish buses are notoriously late and come whenever and very relaxed. And it rains a lot and it can get cold, wet. And that's what he did. He got his friends to track what time the bus actually came at what day, and he built his own bus app model that he gave to people to share. And so and that's just something anybody can do anywhere. Great. And then finally, technology can be used to change the world. And this is so true when you start talking about different things people are doing. Yes, Winnipeg winters are not easy. I was in Minneapolis, St. Paul up until very recently when I went to Microsoft. So I know all about wind chill and cold, and yes. Changing the world is amazing. And this is something that anybody can do. My son's girlfriend is a mechanical engineer student. And as part of their senior year project, they have to come up with an idea, figure out the costs, build a prototype, and all of that, and go through this and actually demo it. And they did glasses that help modulate for the strobe lights so that people who are sensitive to that could go to the movie theater. This is something that they came up with. They went and they did some work. They partnered with, different other engineering students to build these glasses and get the prototype working. And they did studies, and they actually had an investment group buy their design from them. And this is something they did at the university. Just, she's a senior at college, and they came up with this, and that was how their university put together their mechanical engineering. But it's going to be things like that and ideas like that that are going to help change the world. We have so many more people who have sensitivities to different things, whether it's strobe lights or they're autoimmune compromised and they're sensitive to viruses, or they're sensitive to lights, dark lights or bright lights. And
Okay, guys, we're having some technical difficulties here. Remember, you can type your questions on the live chat on the right. So we'll have some time at the end to make some Q&A session. Please stay connected. We're having an amazing speech from Paula. She's having some technical difficulties now. Let's wait her to connect. And we are back.
Okay, so apologies. We did test the Wi-Fi. The Wi-Fi was good. I don't know why today it's deciding to be difficult.
No worries, we're back. So,
Yes.
so no
So
worries.
no, so that's the big thing.
No, fuck. Sorry about that, guys. Please, we we need you to type some questions on the in the chat, please. This is a good opportunity to ask her how to be inspired, for example, how to keep motivated. She's a great leader, data science. Yeah, Nick, it's always, it happens, you know? Well, Natalie, how was my experience working with Paula? Well, you know, I have to say that um, I'm kind of data science lover. I mean, I'm not an expert. I'm in BTN program. This is my first term, and I have to say that one of the reasons that I'm here is because of this new thing related to data science and big data. And I'm lucky that my speaker is one of the best data scientists that we can meet in the field. So it's awesome. She's just such an. I think she's back.
Yep, that was the login. So apologies.
Oh, okay. So now I
Okay,
think we are good. Please continue.
perfect. Let's go to the next slide.
Yeah.
So I just want to talk a little bit about some of the basic steps I do when I figure this out and how so if you've got ideas or you're excited or want to play, you know how to do it. So basically the first thing is you want to create a demonstration. Um, there's lots of opportunities and lots of ways that you can go ahead and get this done. But you can ask and talk to other people, talk to other people at school. Hey, have you ever done this? Have you pitched an idea to a professor for a research project? Have you pitched an idea for, doing some open source, open school sort of thing? And really, not being afraid to do that. And the other thing is always be willing to learn because technology evolves so quickly. In my career, I started before the World Wide Web. And so if you think about everything that's evolved and big data, back then gigabytes was like huge. And now we're talking about exabytes. So, definitely be aware of that. The next thing is, know that we're capturing data and data is available. So by 2025, every day, we, the human race, will generate, and the devices we use will generate 463 exabytes of data globally. And keep in mind, an exabyte is 1,000 bytes to the sixth power. That is a lot of data. And that comes from our IoT devices, that comes from our laptops, that comes from us as humans as we create and innovate. That comes from, that comes from our fitness trackers, our watches, and all of that. So there's a lot out there that we can build upon and do things to better understand the world. And so don't be afraid of it and go out there and learn how to work with big data. Microsoft SQL, PostgreSQL are not going to really scale the way you need. The other thing that's going on is that in addition to having so much data, there's also a general push to make data available in open source. So all of this data that used to be restricted to just a few people, how do we make the data safe to share with other people to innovate? One of my friends is over at the University of California, Berkeley, and he's doing a lot of work about how do we allow public health people and hospitals to safely share data between their clouds, so to protect the patient's privacy, but then to be able to better understand why multiple sclerosis is one way in Boston and a different way in California, and how do we bring all of those cases together. So there's a lot of work, technology's evolving, but the data is going to be there. And even if it's not yet, there's generally open source sets that are available. There's people who've done Kegel exercises or Kegel workshops where they've gone through and done open source stuff to figure out and won prizes, but that data set's available. So definitely, and that's KAGL, don't be afraid to go and look at them and learn from them. Go ahead to the next slide. And so now that you know what you want to kind of demonstrate and play around with, what thing you want to do your what if analysis, who should Winnipeg draft? You can go ahead and you can play with that. You can go ahead and get the data about all of the different things. And then how do you learn? There's papers and tutorials out there. That's one of the awesome things with the MOOCs and with some of the other open source things. There's so many opportunities that you can learn. Generally, you have to pay to get a certificate, but you can learn for free and you can demonstrate and do those things. You can also, YouTube and other places have great tutorials about how do you learn how to do this. Oh, I want to play with TensorFlow. How do I learn to play with TensorFlow? What do I do? How do I, clouds are offering independent, individual, free usage just so people start to use the cloud. Look and say, what is AWS offering for free cloud service for me to play with this? And what data can I put in there and what can I do with their tools? So, Google it, Bing it, DuckDuckGo it, whatever search source you use, but don't be afraid to go look and learn these things. Then there's communities and groups of practitioners that are available. I know in Minneapolis, St. Paul, we have several different groups of people who just get together because they want to learn how to do a better job with retail. They want to learn how to do a better job about working with data securely and safely in the cloud. So look for different groups. And if you don't know, ask your professors. They know these groups and they're willing to get you connected to them, because this is how you're going to get more ideas. At this point, we are trying to build the fully automated self-driving car. We don't need to learn how to build a wheel. We can use somebody else's wheels. We don't need to learn how to build anti-locking brakes. Google the algorithm for anti-locking brakes. You don't want to build that. You want to reuse that. So go ahead and learn what other people have done and build on top of that, because that's how you're going to make a more meaningful impact and go further faster. And then undergraduate research opportunities are huge. Talk to your professors about them. How can you play with them? What can you learn? Sometimes they're at the university. Sometimes they've got colleagues who are in industry or in other areas of research that are looking for somebody who can do some tech work with big data. These are great opportunities to go through there. And then finally, we've talked about open sourcing data. We're also open sourcing tools. Companies want you to use their clouds, so they're going to have free cloud opportunities for you to learn and get familiar with their clouds. Companies want you to understand how brilliant they are, so they're going to make tools available for you to see how brilliant they are. Whether it's PySpark, whether it's TensorFlow, these are open source things that are out there, and people who've done machine learning have made their algorithms available, so you can play with them, you can see what they do, and then you can see if you can do better using different data, using different tools, using different algorithms. But it's all out there. It just takes a little bit of research. Next. So the way I approach these is really very algorithmically. I'm sure you're surprised about that. But identify the problem I want to solve. What is it? Oh, my grandmother wants to stay in her house, but she's shaking. She doesn't have Parkinson's, but I need to keep track of her tremors. Okay, what data do I have? Can I get her an Apple Watch? Will the Apple Watch, the accelerometer and the velocimeter, it'll keep track of the tremors. How do I capture that data? How can I use that data? Can I see, has my grandmother been up and moving, or has she been more sedentary today? Can I use that to call her to figure out what's going on? So figure out the problem. After you figure out the problem, figure out how you're going to get the data to solve that problem. For me, it's how do I make sure that my grandmother can stay safely in her own home? Well, I get her an Apple Watch. I get her to share her data with me for her health data. So now I can see how many steps she has. I can see, is this on par for normal? Is it below? I can see her heart rate. I can see her sleep. I can tell if she's starting to get sick, if I need to do more or be more involved. And I can see what's going on. So beyond just the call every day, Grandma, how are you feeling? What's going on? My grandma's always, I don't feel so good, but it's always the same old things and there's nothing there. But I can tell if there's actually something different. Figure out how to get this data. So like I said, an Apple Watch collects it, but I still need to figure out how to get the data accessible to me. So what is it that I need to do to share this data back so I can take a look at this? Now I'm getting this data. How do I store it? How do I export it into an Excel sheet or into a database of sorts so that I can keep track to say, okay, in the fall, my grandmother tends to be like this because the weather changes this way. In the winter, she tends to feel like this because she's got rheumatoid arthritis and it's very dry. In the summer, it's very hot and humid. This is what it looks like. And I can start keeping track of longer and longer so I can understand not only her day over day, month over month, but also season over season, which, as you know, in Winnipeg, seasons vary greatly. And so there's different challenges, but I can take a look at all of that. And, now I've got the data in Excel sheets. I've got the data in a CSV. I can start to play with it with TensorFlow, with other things, and just get curious. What's normal? I can label the data. I talked to Grandma. She seemed like she was not good. The data seemed like she was not good. I went to the doctor. This is the result. Eventually this is going to be how all of our health is managed. It's not just me and my grandma, but this is what I'm doing right now. And then I got the feedback that I took her to the doctor. The doctor said, this is wrong. How do I update the data? Is there additional data that I should be coming in with? Like maybe her thermostat stopped working and I need to get her a Nest thermostat. And that's why she was so cold all the time, because she couldn't quite tell the difference in her old thermostat. So I need to get her a smart one. Or maybe I need to get her smart lights to give her a little bit more of a happy dose in the winter months so that she's, more alert, more active. But I can figure out what additional data I need, what I need to do. And my end goal is still the same thing. My ultimate problem is keeping my grandmother in the house. But there's going to be those minor problems. Okay, how do I make her happier? How do I give her more energy? How do I make sure that she's, walking around because of her arthritis and not stuck in one spot where her arthritis will lock up? And I can find those problems, repeat the process, and continuously do this. And this is with anything that you innovate on. What's the big problem you're trying to solve? What do you do? Now, what's the next problem you're trying to solve as part of that big problem? Because we never solve global warming. We solve, how do we decrease our carbon emissions? How do we increase our ability to scrub the air? How do we close the ozone layer? It's one problem at a time and solving that. And so this is a great algorithm for that. Excellent. Next. So I wanted to leave time for Q&A.
Oh yeah, we was talking about your speech. So thank you for that. What a great words you have said to us. So I'm gonna go through the questions we have at the chat. So let's start with this. Duncan said, "I am very interested in machine learning and data science. I intend to pursue it as a career path going forward. If I were to start on machine learning today, which category would you recommend for starting my studies?
You know, everybody likes to go right to neural networks because they're so powerful and they're so fun. But I think that it's just, some of the basic machine learning algorithms are great. So I would recommend that you download just a basic introduction to machine learning tutorial and go through that. And you'll go through very simple algorithms, whether it's Bayes or linear regression or CNN. Well, CNNs are get into the more convoluted belief networks, those sorts of things. So I would start there because it's very fundamental and it helps you to understand how the data fits. What I found actually is doing a random forest is a great way for me to really get a good feel for my big data and where some of the outliers are, what's going on, what data really is relevant or not. And so a lot of times I'll do a random forest quick to understand some of that, and then I'll pull it out and maybe go and play with some of the other stuff inside TensorFlow, understanding my learnings from the random forest. So that's how I would recommend, Duncan, and just start with the basics and understand that, because the biggest thing you need to do for machine learning is really to understand your data. And so many people forget about that. But if you don't have the right data, no neural network is going to really give you accurate results. And so using some of the more basic machine learning categories, I find very effective for really getting to learn data and being more effective with TensorFlow and other sorts of neural networks.
Sounds good. Thank you. Let's go for another more general. Kanambir is asking, let's imagine that we want to break into the software industry today. What do you think are some of the important skills that we should really focus on?
Yes. So I think really, if you want to break into software engineering, the biggest thing is to know your tech, be able to code, because nowadays every company has a technical interview where they'll say, okay, I want you to write code to take and reverse all of the letters. So if you get a string Paula space Greve, how do you turn that to Avegra Alup? And how do you do it the fastest way? So really understanding the how to solve these problems with code, and then understanding the efficiency. Those are two key skills to pass the tech interview and to get started in software engineering and technology today. That is key. After you've mastered that, then go to the cloud. Everything is in the cloud. Go to working with data. Everything is about data. So that would be the next thing to go after you've mastered the basic software and the software coding skills and understanding the efficiencies of algorithms and how that works and the fastest, best way to do this at scale. The next thing then is to be able to talk about what you can do in the cloud and being familiar with some of the basics of cloud programming.
Wow, awesome. What an answer. Um, so let's go with Sam Lee. So Sam is asking, he's worrying about the workload. So how to manage it and what did you do in your free time?
Oh, you know, that's really a challenge. And it's a challenge even for my son. So I don't know that I'm going to be all the best to help with this. Given that my son already said this week was really horrible and he's just fried and things aren't getting done as
Wow.
fast as he wants to. And so I think the big thing to know is that everything ebbs and flows. There's times where I'm working 60 hours a week and I can't get it all done. And then there's other times where I'm working 30 to 40 hours a week and have time to learn or do additional things. And so the first thing to do with the workload is know that it's a series of sprints, but it's so important to have your rest periods in between sprints. And they say it's a marathon and not a sprint, but it's a whole series of sprints is what I found, where you're going to get crunched and then you're going to have space. And so just know that and be okay with that, and don't beat yourself up about that. The other thing to know is you really have to determine what is good enough. So many people are so used to like doing the right solution and getting it perfect. And the problem is, even in industry, we do not have enough time to do the right solution. We have to do the good enough solution. And that's why when you learn agile programming, you hear things like minimal viable product and minimal likable product. And that's because we have to figure out what is the bare minimum thing that we need to do, and then nail that, do a great job with that, and then you can come back and do the other stuff. So it's really about, not trying to do the perfect solution, but trying to do the good enough, the accurate solution. And then if you've got time, you can come back and do more. For me to decompress, I like to go hiking. I like to play. Sometimes I like to just unplug and just
And you
do.
told me that you do it by yourself, right? So I
Yeah.
told you just to be careful because being in the woods by yourself. But now we are talking about technology, so you have all the devices ready to
Yes.
take care of you.
Yes, I make sure that I make sure if I'm going to go anywhere that I don't have cell phone coverage, that my husband knows where it is
Yeah,
and where I am and how long I should be expected to be gone, in case, so he can keep an eye on me in case there's an issue. But really, with devices nowadays, I use those, and I make sure that I know how to, and I stay on the trails when I'm by myself. But it's just, the technology has really enabled us to be able to do more, especially with COVID. I know a lot of people are still by themselves. And so it's given me the freedom just to kind of unplug and think my own thoughts.
that's right. We should take advantage of that. Okay, that's a lot of questions here. Now I have to start picking up. I like this one. Uh, Elias said, "Do you ever feel worried about having all of our data just out of there, being
Yes.
accessed with little to no oversight?" I think you mentioned something in your speech. What you have to
Yes.
say about it?
No, that is very much a worrisome thing. And
Yeah,
and then how companies who have our data, that how they can change what they do with it with all of the different data agreements. So it is very disconcerting. It's also disconcerting how long companies keep some of the data for me, on me. There's no need to keep an email address I used 10 years ago that has not been used since. And I found that was the case when Target was breached a few years ago. And I was like, why do you have this email address I have not used for over 10 years? It makes no sense. So it's really disconcerting. I think that we're doing a lot to improve data responsibility. I think we still have a long ways to go. And it's going to be hard because there's definite advantages to knowing things about your data, like to get your DNA, right? There's things you can tell with DNA, like if you're at risk for celiac or if you're at risk for other things. But there's also like what other people can find out, like, oh, well, you're my you're my you're my second cousin, and you find out a grandparent had an affair or something like that, and you never knew about it. And and all of that's good. People need to have a sense of belonging, a sense of home, but there's unintended consequences. And so it's just a real tough balance. So I tend to be very careful about who I give my data to and what data I give to them. And then I'll go through and do random checks where I ask, can I see what you have about me, and all of that. Eventually, this will not be something any of us have to do. The government will mandate that people who have the data do that. But the problem though is that it's also at some point we're going to need somebody to have all that data. They're going to need to have my DNA. They're going to need to have my body temperature, because as we age and as our population grows and as we go through the next pandemic, whenever that may occur, we need to have that level of personalized visibility. We just need to make sure it's protected.
Absolutely. That's a concern. So let's move to another one. Guido said one of the biggest problems in machine learning is maintaining the models. Can you share some tools to allow users to provide feedback on the models?
Yes. So, this is something I have not found super good open source solutions for. They're out there, and it could be that they're good, but because I'm in a commercial environment and I haven't tried to use them for my own personal things, they haven't. I haven't looked at them further because of the cost. So I've just built my own. And every place I've been, we've kind of built our own human in the loop, human machine teaming, where how do we get the telemetry back if they disagreed with our model, and how do we bring that back to look at this? How do we measure drift? There's a lot of good technical papers about how do you measure drift and what do you need to do about that. So I would encourage you to read up on that, and they may have better tools, open source tools available for that. But that's generally what I do, is I look at what the eventual ground truth is, measure the drift, and then understand what the humans are saying. Now, one thing to note is I've actually found in some things my machine learning algorithms are more accurate than the humans and the human subject matter experts. So you can't assume they're right. You need to get validation not only on your machine learning models but on your human reviewers as well, and then take that into account as you look at the feedback.
Yeah, that's right. So this is a good one. I think we always are having some concerns about this. How to build? This is from Kichunyu. Kichunyu, I think I pronounced well. Sorry, Kichun. How to build a prototype when you don't know where to start?
Yes, that is a great question. I think you've got to start with the problem. What is the problem that you're trying to solve? And then if you look at the problem, you're able to then go and figure out how to what you need to what the solution should be. So if the problem is that you want to keep your grandmother in her home, right? Then what do you need to do? What does that solution look like? Well, the outcome's my grandmother in her home. Well, in order for her to stay in her home by herself, I need to make certain that we know that she's okay. So what does okay look like? How do we tell if she's okay? So generally that's what I find. If you're going to build a prototype, start with what is the problem you're trying to solve? What does that solution look like? How do you get that? And then you can look at other things. Like you can look at other universities. A lot of times they'll do things like, here's the research presentations of people, and you can hear how they came up with the idea to do a prototype. You can watch films like the Social Network or other things. Even if they're even some of the more humorous ones like The Internship, that are just not even realistic, but they still talk about how they came up with a prototype of how do we make sure somebody doesn't drunk text or something like that, and you can see their thought process. And I think that's the biggest thing, is to read more about how other people have done it and follow their things. But you have to start with the problem. You have to start with what does solving this look like, and a lot of times that's going to take you 75% of the way to figuring out what your prototype should be.
Yeah, prototypes. Yeah.
That's a tough question. That's a tough problem.
Yeah, but always asking the same. Well, how to start? That's a tough situation. Okay. Also, there is another one interesting. Man Wally is asking, People said algorithm is polarizing our preference on information.
Yeah,
What kind of improvement can we do to balance the information taken so that the bias can be mitigated?
that's that's tough. I mean, I think if you look at responsible AI is trying to do that. So that's going to be probably some of the best research on that. There's things you can do, like I've seen them, okay, well, we're going to remove the bias in resumes by removing the name and having machine learning select who's going to get brought in for an interview. But then they showed that there's just bias because females write their resumes different than males. Um, uh, indigenous people write their resumes different than non-indigenous. And so there's still just inherent things in even that basic data. Um, so really, it's going to be one of the critical problems we need to solve as machine learning goes. And there's a time and a place for keeping some of that bias intact. And then how do we remove that bias? Another great thing is like customers, right? So if I'm trying to increase customers who spend so much money on coffee at my store, I'm going to want to say, okay, well, who are my customers that spend a lot of money on coffee at my store? How do I get more customers like those? And then you really could start to just target just all the same customers and lose all your diversity. So, it's really important that you're looking at all of the data and understanding that. And definitely you can do weighting so that you can say, I don't want to bring in just these sorts of people. I want to bring in everybody. So I want to weight more towards this. And there's things you can do with weightings to try and adjust it. But really, responsible AI is the best research in the field, and they can talk about it a whole lot more than I. I know that we're always looking at that. How do we make sure that we introduce anomalies and see how they pan out to make sure that our algorithms don't force a total, likeness, but it's a journey.
It's a difficult one. Okay, let's talk about a question from Antonio Teixeira. He said, as a data science and machine learning program student, what are some of the things that make an individual stand out for internships or entry-level jobs in the field?
Yes, I think that this is where what are you doing for undergraduate research? So did you spend some time doing a research project? What self-started projects have you done? What can you say that you've done with data above and beyond just what your university is? So really, if you're a student looking for that first time job or for an internship, it's that additional layer of things that you've done above and beyond just your university projects to try and pull that in. I know my son really wanted this internship, and so he took his winter break and played with the data. To see if he could do a prediction model. So then when he applied for the internship, he was able to say, oh, and by the way, I posted my model online, check my model out.
Mm.
And he was the only undergraduate who was selected to have an interview for that internship. Everybody else was a graduate student. And so sometimes it's just doing those things, making sure that you're not afraid to take what you've done, post it online for people to talk about and share it, and try and participate in different competitions, try and do undergraduate research projects, and really be able to talk about how you can see things from end to end. And that's really would be my advice.
Oh, great. Thank you for that. How about Natalie del Carmen? She said, could you share with us about the data project you've worked on where you encountered a challenging problem?
I think every data project I've worked on, I've encountered a challenging problem. Some, I think, from learning that the humans who are the subject matter experts were not guaranteed to be better than my machine learning algorithms. That caused us to pivot and find things to, having data that was too big, that it was too expensive to work with, and we had to figure out how to tone down the data to get a more manageable set, to really having the people who I was trying to solve the problem change what they wanted, right? So originally they just wanted to know, I want to be able to recommend products for people when they check out. And then, oh, but wait a minute, I never want to recommend cigarettes to people when they check out. Oh, wait a minute, I never want to recommend alcohol to anybody under the drinking age when they check out. Oh, and so they change all of that. But I think right now the biggest data problem I run into is having the right data available.
Yeah.
So with customer insights, we build a product that our customers can import their data on, and they can get insights into what's going on. And most of our customers do not have the right data. And so then it's just, how do you educate them that, okay, now you can start. And that's why I said the biggest thing, for learning machine learning is understanding, and being a data scientist is understanding what data needs to look like and what data you need to have to solve the problem.
Cool. Okay, we have only 3 minutes left, so I would love to thank you all for your questions. We love to have like 1 hour more, right, Paula?
I'd
But
love it.
yeah, we are so grateful to be here and listen what such a data scientist talking about data and life. So I have a personal question for myself. Is imagine that you have a time machine and you can go back in time and you have the opportunity to talk to the young Paula. What would you a good advice to her, to young Paula, looking at what you are achieving now as a great leader that you are?
Oh, there's a lot of things I tell young Paula. Um, I think one is that relationships are as important as your skill set. And you can work super hard, but if you don't have people who understand that you're a hard worker and what you bring to the table, your career is going to stall. The other thing that I would tell young Paula is that when you first start working, it's all about, like in college and everything, it's all about how hard you work hard, you get good grades and all of that. But when you get into industry, when you get into business, it shifts. And it's not just about how hard you work, but how much you are able to manage your manager, or like your cases, manage your professors, manage your advisors, right? But how much you can get them to believe in you, and to spend more time making sure you've got this really, not just let my work speak for itself, but making sure that my manager understands who I am, how powerful I am, what I want to do, as well as making sure I've got other people who do that as well. Because they can say, oh, Paula's a hard worker, she gets all this done, but they're never going to say, oh, I want Paula to lead this project because you're the hard worker who always gets everything done. And so it's really important to establish those relationships and get those people. And that's what I would tell young Paula.
That's right. That's right. Before, some years ago, we are only thinking in hard work, study, work, and now we have relationships together. We have that. We are talking about uh, psychology team, soft
Mhm.
skills and everything. So nice answer. Thank you, Paula, for your time. We really appreciate all the words, the kind words that you just said, and we hope to see you again.
Thank
This is the an inspiring conference, and I think we are all inspired by your words. So thank you for that. I really appreciate it, and hope to see you soon.
Yes, and thanks everybody, and just know that truly it's seeing what all of the college kids are doing now and the people entering the workforce are doing now. That's what inspires me. So thank you so much, and I hope I get a chance to meet and work with you in the future.
Absolutely. Thank you guys for joining, and please be safe, be warm. Bye-bye.
Bye.
Bye-bye.